Hi, in this video, we're going to introduce VLANs. So definition of a VLAN. There are several out there. This one's from Wikipedia. A virtual LAN, VLAN, is a broadcast domain. That's the key part there. It's a broadcast domain that is partitioned and isolated in a computer network at the data link layer, OSI layer 2. So when we think of VLANs, we usually think of a broadcast domain within a switch or group of switches. Okay, so typically when we think about a layer 2 switch in the past, we've been thinking of that, oh, it doesn't have VLANs. But a Cisco switch really does have a VLAN. It's just that all the ports are in the same VLAN, which is VLAN 1 by default. So if I did show VLAN, I can see that it is listing all the ports for this switch in the same VLAN, VLAN 1, which is given the name default by default because it is the default VLAN. Okay, so what does that actually mean? All right, if we have these 4 computers all connected to this same switch, can they communicate with each other? Well, yes, and that is because, first of all, they can communicate with each other directly without going through a router because they're all on the same IP subnet. So in the previous video, we talked about how devices determine what network they belong to and also what network the destination IPv4 or IPv6 address belongs to. So these devices all know that they're what network they belong to, and if they want to ping each other, they all know that the other device is also in their network. So yes, A, B, C, and D can all ping each other. Well, okay, what if host A did a ARP request for host B? Okay, wants to send it a ping, knows its IPv4 address, but does not know its layer 2 MAC address. Well, it would send out an ARP request, right? And an ARP request is a broadcast. And what does a switch do with that broadcast? Well, it floods it out all ports except the incoming port. Well, really what it does is it sends it out all ports that belong to the same VLAN as the incoming port. Oh, that's a key thing there. It came in on a VLAN 1 port, so the broadcast is going to be sent out all VLAN 1 ports. All right. Well, what if we did this? What if we segmented the switch into, in this case, 2 VLANs? And sometimes we use colors to instead of subnets to refer to them. But the VLAN is a logical layer 2 partition. Okay? We can have multiple partitions, multiple VLANs coexisting on the same switch. Each VLAN is a layer 2 broadcast domain. What that means is we associate each VLAN with its own IP network. So a VLAN nowadays we associate with an IP network or subnet. Okay. So VLANs are mutually isolated and packets can only pass between them via a router. And I'm going to show you this in a moment that we need, even if the devices were on the same VLAN but different subnets, they still need a router to communicate. Remember, device lives in a bubble. It only knows its own IP network information. I'll come back to that in a moment. Okay, so the partitioning of the VLAN happens in the switch. The devices connected to the switch are completely unaware of any association with VLANs. Let's take a look. Okay, so let's say that right now we have our switch all configured with the single VLAN. Sometimes we think of that as no VLANs, okay? So who can communicate with who? Okay. Well, we're going to need a router for devices to intercommunicate. So which devices can ping each other? Okay, A can ping B, and B can ping A because they are on the same IP subnet. Okay, C and D can ping each other. Okay, but it's important to note that A cannot ping C, even though they're connected to the same switch, even if they're on the same VLAN. Why is that? Well, we talked about that in a previous video. Okay, remember what A knows is knows its own IPv4 address and subnet mask. It does the bitwise AND operation and knows that it belongs to the 192.168.10.0 network. Remember, these devices live in a logical bubble. So if it had a packet to send to C, it would see that the destination IPv4 address is 192.168.20.12. A would use its own subnet mask, because it doesn't know the subnet mask of C, do a bitwise AND operation and realize, oh, hey, C is on another network. The only way that A can reach C is via a router. So we need a router involved here. Okay, so we'll be taking a look at that in more detail here shortly. Okay. So a single VLAN or no VLAN means no segmentation. So what if A was going to do an ARP request for B? Okay, again, it's going to ping B, knows its IPv4 address, but does not know its MAC address. It's not in its ARP cache. So it's going to send out a broadcast. Now remember about the broadcast, right? The switch is going to flood that broadcast out, that layer 2 broadcast out, all ports that belong to the same VLAN as the incoming port. Well, guess what? B's going to get it, C's going to get it, and D's going to get it. C and D never need to see an ARP request from A, because it's never going to respond to an ARP request from A, because A is never going to ARP for the IP addresses of C or D because they're on a different network. A will only do ARP requests for devices on its own IPv4 network. That also includes its default gateway, the router, okay, which we'll be talking about here in a moment. Okay, but if we were to segment this switch into multiple VLANs, into 2 VLANs, then the ARP request would be isolated to just those ports that are in the same VLAN as the incoming port. So the ARP request comes in on this port and is going to go out only any ports associated with the same VLAN. This is why we want devices. And again, devices are unaware that of the VLAN configuration on the switch. But it's important, very important, that we associate the IP addresses of our devices with the VLAN that they belong to. So all the devices on the 192.168.10.0 network, okay, they're going to belong to this VLAN here, the same VLAN. All devices on the 192.168.20.0 network are going to belong to the same VLAN. Okay, and we can even have these, they don't have to be contiguous either. I'm showing ports over here that are on the blue and red VLANs that are not contiguous, and that's fine. We can have these gig ports be configured separately. We'll see the configuration in another video. Very easy to configure. Okay, VLANs and IP addresses and subnet masks. Okay, VLANs are configured on the switch port. Okay, again, devices are assigned network addresses, and we learned how that's done with IPv4 and IPv6. The VLAN on the switch must match the IP network address of the device. Okay, so I said VLANs are configured on the switch port. Again, devices are totally unaware of the whole concept of VLANs, but they are aware of the concept of IP network addresses. So we want these 2 devices configured for, this range of switch ports configured for VLAN 10, this range of switch ports for VLAN 20, this one configured for VLAN 10, this one for VLAN 20, And then we make sure that any of the devices that we connect to those VLANs belong to the same subnet. Okay. So as we can see here, A and B are devices on the same subnet connected to the same VLAN ports. C and D are on the same subnet connected to the same group of ports on the same VLAN, VLAN 20. All right. And as you remember, I talked about in previous video, an IPv4 device, IPv4 devices use the AND operation between their IPv4 address and subnet mask to determine what network they belong to. IPv6 devices use the on-link flag and prefix in the router advertisement, which tells them what prefix or network address they belong to. Okay, so if I did a show VLAN, so before any configuration here, this is the default, show VLAN, we see that all ports are on the same VLAN. Okay, so any devices we connect to the switch, if we want those devices to be able to communicate with each other directly, they need to be on the same subnet. Okay, but let's say we want two of our devices to be on a separate subnet. And again, let me mention, you do not need VLANs to do this. C and D can communicate with each other, no problem, and A and B can communicate with each other, no problem, without VLANs. What does VLANs buy us? It segments the broadcast domain. Okay, so any broadcasts from A will only be seen on these blue ports, and any broadcasts from C or D will only be seen on these red ports. So it's all about segmenting broadcasts. Okay, so after the configuration, and we'll learn how to do this in a separate video coming up, but we can see that now we have two VLANs, a VLAN 10 and a VLAN 20. Okay, and we'll talk about why we number them this way, but you can number them any way you want. I chose 10 because this is kind of our subnet address there, 10, and 20, this is our subnet address here. Okay, just makes it easier to recognize which VLAN. So you typically will have an IP scheme, addressing schema and a VLAN schema, and it's nice to be able to match those if you can. Make it easier for you. Okay, so router and subnet. So a router is required to connect to route between the subnets or VLANs. Okay, so if we want these the A and C to be able to communicate with each other, guess what? We need to have a router involved. Okay, so first I'm going to talk a little bit about this, but before I do, let me mention that having these two ports on the router, one for each VLAN, is a legacy way of doing it. We can do this with one port called a trunk port. Okay, we'll learn about that later, but for simplicity, we'll just keep it two separate ports for right now. All right, so if A was going to ping C, okay, first of all, check its ARP cache and says, well, first it would say, hey, I'm in this network, 192.168.10.0. The destination's in 192.168.20.0. We're not in the same subnet. Okay, so I'd say, well, what's my default gateway? And it's, let's see if I have it on here. No, I don't think I do. I took some addresses. Oh, here we go. Yes, this is going to make my life much easier. Okay, here we go. So I have MAC addresses and everything. Great. But there's one thing I'm missing here. I need a default gateway address on A. So we put the default gateway. I'll just write it right here. 192. You know how well I write here. 168. And the default gateway is going to be the IP address of the router. 10.1. There we go. I can fit it in there. Okay, looking good here. Okay, so A wants to ping C. Okay, it says, well, we're not on the same network, so I need to send a packet. I need to send in my packet to the encapsulated Ethernet frame with the destination MAC address of the default gateway, the router. So it's going to look up the 192.168.10.1, that's a 1 there, in its ARP cache. Okay, we'll look it up in its ARP cache. If it's not there, it's going to send out a broadcast. Says, hey, who out there has the IPv4 address 192.168.10.1? Send me your MAC address. So everybody, so this broadcast will come in here and will go out all ports associated with VLAN 10. Okay, so it came in on a VLAN 10 port. So this is from the switch's perspective. So it's going to say, I'm going to send the broadcast out any ports that belong to VLAN 10. Okay, so the router will receive it, says, oh, that's me. Let me send you my MAC address. So it will send back an ARP reply. And that will go back to A, and it will put the MAC address of 192.168.10.1 in its ARP cache. It'll associate that with its ARP 1111 there. Notice that that broadcast did not go out any of these VLAN 20 ports. Okay. So as far as the packet is sent, so the packet is actually sent. Let me see if I can, let me actually clean this up a little bit. There we go. So the packet's going to be sent from A to the router. Then the router is going to route it. Okay. If it needs to do an ARP request for C, it will, and get an ARP reply from C, but it will then send it out this port here, associated with 192.168.20.1. Think of it almost, that's what, what a router does, right? Connects different networks and then send that packet to C. Okay. So it's almost like these were two separate switches, but they happen to be on the same switch. And the router is just receiving it on one interface connected to that switch and sending it on another interface connected to the same switch. Now, typically, we're not going to do this with two ports. Typically, we're going to do it with a single port called a trunk port, but that's for a later discussion. But what I want you to see here is that we need a router to communicate between two devices on different networks, whether or not we're doing VLANs. That has nothing to do with these VLANs. That has, we could have all these ports on the same VLAN. A and C still can only communicate with each other via a router. What the router does, the VLANs do for us is segmenting that broadcast domain. When we sent out the ARP request, the that broadcast only went out the blue ports. All right, so I hope that helps you see the importance or the benefits of VLANs. Okay, so VLANs help us with security. Okay, we can isolate different parts of our network, sensitive data and applications from each other. So there's no possibility of unknown unicasts being flooded out and somebody seeing something they shouldn't. Okay. We'll see how it can do for cost reduction, reduces the need for expensive network upgrades, more efficient use of the bandwidth and the uplinks. And we'll see that with trunk ports, smaller broadcast domains. Okay, so that's going to, if there happens to be any problem with something called a broadcast storm, where it's a bad nick is on our network from some devices constantly sending out broadcasts, that's not going to affect our entire network. Okay. Gives us better performance, okay, and makes it a lot easier to manage. Okay, so by the way, how many VLANs can you configure on the switch? Well, it depends on the switch's capabilities and what you require, but we'll take a look at this more later. So typically, on Cisco switches, we can configure in a range of 1 to 1,005 VLANs. Now, 1,002 to 1,005, as we'll see later, are reserved for legacy token ring and FDDI. Okay. VLAN 1 we'll talk more about in the next video. when we talk about VLAN types, but that's the default video of VLAN, and that VLAN cannot be removed. We'll talk about the VLAN DAT file where all the VLANs are stored. There's also a group of VLANs called extended range VLANs, and we can have that's 1006 to 4094. 4095 is reserved. The reason they came up with this number is we'll see later it has to do with VLAN tags and the 12-bit VLAN ID associated with it. So 12 bits allows us for up to a number of from 0 to 4095. 0 and 4095, we cannot use those numbers, as well as some of these others like 1002 to 1005. Okay. Might seem like a lot of VLANs, but believe it or not, in large enterprise and service provider networks, 4,000 VLANs isn't enough. So, which is another reason why we're looking at other things, and being able to go to IPv6 will help us with that. But that's for another day to talk about that. All right, so that's a little introduction to VLANs. A lot more coming up.